Let's look at graphs of the form y equal ax to the n, where a and n are constants and values of n include -1, -2, and +3. One example could be y equals x to the -1. Simple example. So let's look at that. We want to plot x raised to the power of -1. Okay, so there you have that graph. Let me make the curve thicker. Good. So this is the graph of y equals x raised to the power of -1. All right. Now, as you can see, if we get close, very close to zero, to the origin, we try to plot a point when x is 0, what we would have is y is equal to 0 to the -1. But what is that equal to? Remember that x to the -1 from indices is mean the same as 1 over x to the power of 1, which is 1 over x. So 0 to the -1 means the same as 1 over 0. And you cannot do this. You cannot divide by 0. This is indeterminate. That's why you see the line, it goes up and up. It's actually towards positive infinity. No matter how far up you go, it gets closer and closer to the y-axis, but never touches it nor cross it. In this case, what you're really saying is that when x is 1, what we have is y equals 1 to the power of -1. But 1 to the power of -1 is the same as 1 over 1 to the power of 1, which is 1. Alright, so you have 1 for x, 1 for y. Right here. When x is 1, y is also 1. Here, you have y equals -1 raised to the power of -1, which is the same as 1 over -1 raised to the power of -1. But -1 raised to the power of +1, I should say. But this is just -1. So when x is -1, y is -1. And as you get closer and closer to x equals 0, you have the values go down to -infinity. So you do not have a y-intercept. Do you have an x-intercept? Does the graph touch the x-axis? Let's see. If the graph should touch the x-axis, then y would be 0, right? It would touch the x-axis at y equals 0. Because, remember, right along here would be when y equals 0. Up here is y equal 1. Down here is y equal -1. Right here is y equals 0. Let's see what would happen here. If y should be 0, then 0 is equal to x to the -1. So 0 is equal to 1 over x. What would x be? This is 0 over 1 equal 1 over x. If we should find the reciprocal of both sides, we will have 1 over 0 is equal to x over 1. So x would be equal to 1 over 0. 1 divided by 0, you can't do that. It's indeterminate. So again, the curve gets closer and closer to the x-axis, but never touches it, right? It will not touch the x-axis. No matter how far out you go to the right, it gets closer to the x-axis, but will never touch it. No matter how far out you go to the left, same thing. Now, there's a certain name for this. Since the curve gets closer and closer to the y-axis but never touches it, never crosses it, then the curve is an asymptote to the y-axis. It's an asymptote to the y-axis. Now, the curve also gets closer and closer to the x-axis but never touches, never crosses it. So it is also an asymptote to the x-axis. Alright? So remember, this is a graph of y is equal to x to the negative 1. Alright? So that's what we have. Suppose we make a little modification and say, instead of x to the negative 1, let's say y is equal to 2x to the negative 1. What would happen? Let's see. 2x to the negative 1. Okay. The graph goes out a bit further. Because when x is 2, we're going to have 2x to the negative 1, but it's 2 times 2 to the negative 1, which is 2 times 1 over 2, which is 1. So when x equal 2, y is 1. Now, what we want to do here, let's put it back at x to the negative 1. Oh, let me redo that. X raised to the power of negative 1. Good. So in black, we have x raised to the power of negative 1. Suppose now we have in green y equals 2x to the negative 1. So let's plot that graph. 2x raised to the power of negative 1. And that's what we have. Let me make it thicker and put it in green as well. So I put it in green and I make it thicker. Okay, so the green graph is 2x to the negative 1. Right? So it has the same general shape. However, it has larger values because each value in x is multiplied by 2. Now, if you make it half x to the negative 1, it should have smaller values but have the same general shape. So it's 1 over 2. Let's put 1 over 2 in brackets, x to the negative 1. Good. That's what we have. Alright. Now, let's make another modification to it. In this case, what we're going to have is x to the negative 1 plus 1. X to the negative 1 plus 1. So let's change our green graph to that. We have x to the negative 1 and plus 1. As you see, all points move upwards by 1 unit. Let's put it back. Then what we're going to do is go into the raised to the power of negative 1 part. Instead of x alone to the negative 1, let us say x plus 1 to the negative 1. So we have x plus 1 raised to the power of negative 1. Alright, let's see what will happen. So x open bracket x plus 1 close bracket to the negative 1. It was the black graph that we modified a while ago. I want the green graph to be modified. What happened? They were lying down right on top of each other. When I selected, I didn't know whether it was the black or the green graph that I actually selected. So x plus 1 close bracket to the negative 1 plus 1 close bracket to the negative 1. Okay, x plus 1 to the negative 1. It makes the alright, let's put this back as x raised to the power of negative 1. Okay, alright, here now I want to show the labels. So we can clearly see what we have here, which label the black graph is showing, right? And then the green graph. So the green graph is saying x plus 1 to the negative 1. It's kind of dull here. Let me change it to blue. It's darker. Alright. The green graph, the blue graph is x plus 1 to the negative 1. The black graph is just x squared, right? Or not x squared, x to the negative 1. The black graph is showing x to the negative 1. Right? Now it's x to the negative 1. Now what you have here is a movement to the left. Each point on x to the negative 1 is moved one place to the left. You can see that, right? Each point on negative 1 is moved one place to the left because you have x plus 1 to the negative 1 now. And then if you should have minus 1, x minus 1, let's modify it. Minus 1 to the negative 1. Each point is moved to the right. So the general movement is similar to that of the quadratic graph, whether it's up, down, left or right. Alright? So if you go inside the power being raised and add or subtract a number, you're moving to the left for adding a number, to the right for subtracting a number. If you go outside the power, when I say inside the power, is that what you raise to the negative 1, the number you add is included. When you go outside the power and add a number or subtract a number, what you're doing is shifting up and down. If you add positive number, like positive 1, you're moving the graph up by 1. And if you subtract, we say you're minus 1, you're moving the graph down by 1. Alright? So it's a similar operation as that for the quadratic function. Alright. We're going to look at what happened when the power is -2, but we'll do that in a different video. So I'll see you then.